that we as designers or users or evaluators of interactive systems have to deal with. And my emphasis here is to try to serve the user. I don't like the term user-friendly. It's a term that grates on my nerves. It is not scientific. I don't know what the units of user-friendliness are. And I don't think people want friendly systems, you know, good morning, Jim, I see you haven't been on for 72 hours, I hope you're feeling well, you know, or hi, Tom, you're doing great, you got 72 of the last 78 commands syntactically correct, you know. I don't think people want that kind of chatty behavior, even from bank machines or teller machines and so on. What they do want is a clarity of design that gives them the sense of their own control over the system, that they know what's happening, that it is predictable, that it is consistent, and that they understand what's happening. So that when they're done, they have a sense of their own competence, their own mastery, not somehow that the magical system has done the job for them, but that they are in charge and that they have accomplished a good piece of work using a powerful system that enables them, that empowers them. Okay? So the ways of accomplishing that now are separated out here in this slide. First aspect of design, and foremost, is going to be making task-suitable functionality, getting the right set of features in a system. Now, this is hard work. You have to know what the worker's role is and understand what they're doing. The dangers here are twofold. Of course, excess functionality, where you've put too many commands, and I've seen word processors with 720 commands in them, that with 1,000-page manuals that, of course, people don't use, and they feel overwhelmed by it. On the other side, there's the danger of missing functionality, and what frustration to be looking at a screen and not be able to save it, not be able to print it, not be able to sort it, not be able to send it to someone else, and having to retype the same information. That is wasted effort. That is missing function in a system. Okay? Now, it turns out users adapt a narrow subset. In a study at IBM Yorktown Heights Research Lab, Mary Beth Rawson evaluated the profiles of usage of experienced users of Xedit, a system with about 160 commands in them, and no user used more than 42 of the commands on the system, and the typical set of commands was on the order of 24. So people adapt a narrow subset and use them with high frequency. Yes, I know there are certain commands that are used once a year or in emergency situations that are necessary, but still, the evidence is quite strong that people adapt a narrow subset and they use them with great fluency where possible. So the central goal of designers is task analysis, and the central for users is also to evaluate whether the system provides the features they need. Then, of course, security, reliability, availability are necessary components of a good design. If the machine is down or loses your data or corrupts it in some way, it's not user-friendly and it doesn't serve the user's needs. These are basic system design issues, of course. Then there are sort of integration questions, standardization, and I'll be talking about that in a short time. This is a very powerful force now emerging. There are many pressures for standardization and guidelines, and they have tremendous benefits to doing it if it's done properly. Portability to other systems and integration with existing software are also important design components. They're not the specifically user interface, but they're components of serving the user. Of course, the speed and response time display rate should be rapid. People prefer, in general, to go faster and faster, although there is some danger of being too fast, producing higher error rates or greater burnout. So there are some dangers on that side. Now, the features to look for in the user interface are the input devices and the strategies. Just because you're using a touch screen doesn't tell you enough about it. And just because you're using a keyboard or a pointing device doesn't tell you enough. It's how these devices are put to work. One of our pleasures is that we've developed touchscreen strategies that are far superior to the existing ones, that allow people to point to even a single pixel on the screen in a smooth and continuous way. The usual domain of concern for user interface are the menus, the form fill-ins, or the command languages. And in the previous course, the 5-hour course I did last year, there was a detailed discussion of these 5 interface styles. So I'll be brief today. The natural language is promised as a user interface style of the future, and as people may know, I'm somewhat skeptical that that will be the dominant force. I much prefer this strategy, which I'll talk about later briefly, the idea of a visual representation of the world of action, includes the objects and the actions on which the user can do their job. The output side, of course, is very important. The screens with multiple windows and color and sound, we'll be talking about those things briefly later. Text organization and presentation, I'm pleased that the quality of screens is dramatically increasing. Old screens, I think, should be dumped. We had considered for this broadcast of taking an old terminal and smashing one, dropping it off the building in David Letterman style, but I think good judgment got the hold of us. And I think the point, though, is that the quality of newer display screens is dramatically improved. Reading speeds can be increased by some 30% and come close to matching reading off of typewritten materials. So there is a response in the industry, and the newer screens are definitely superior. They're more readable and also getting to larger screens, which we'll be talking about soon. Other aspects of that user interface, that's part of the output side, the instructions, the error messages, and the help. And one of my pleasures to see the improvement in the error messages. It's been an issue of mine for some 10 years of getting us past the nasty messages of, fatal error, run aborted, and disastrous string overflow, job abandoned, all of that nasty kind of condemning thing, or even the brief nasty messages like syntax error, invalid data are beginning to disappear, and the more positive, constructive, informative messages are more and more prevalent in the systems that I see. So for me, there's a great satisfaction that that issue, which we had studied some 10 years ago and had done a series of 5 experimental studies and shown results, we now see the progress and the improvement in the systems, in many of the systems, not all. I still collect nasty messages. Please let me know your favorite one. All right, beyond that, I see more interest in recent years in physical actions of machines, that is control of robots or other devices at remote sites, at remote times, and also communication with the rest of the world. So we're sort of branching out from computers being purely operating on words and numbers, but operating in the physical world and communications with others as well. The final aspect of user interface I've listed here are the manuals, the tutorial, and the training, very important components. In terms of the study of these systems, we're seeing, and my emphasis is on this reductionist approach on one side, following a more scientific and evaluative approach to separate out who the users are and what are the tasks they're accomplishing. Sometimes we even make a table with the users and the different categories of tasks, user 1, user 2, and task 1, task 2, and then who's doing what and how often each person is doing each task. This is a very important guide for the design of systems. One of the principles is that the frequent tasks be most efficiently designed, most effectively designed. We over the years, come to measure these categories: the time it takes for a particular user to accomplish a particular task, the speed of performance on benchmark tasks, the rate and distribution of human errors, one of the most important aspects. It should be possible to capture the frequency distribution of errors on systems that you either buy or create. It should be possible to measure what are the 10 most frequently made errors, because then you know how to go about changing training, changing the system, changing manuals, changing instructions. And then we always are interested in the retention over time. We want systems which are easy for people to remember from one week to the next. The last category goes more to the holistic and the subjective view, which is subjective satisfaction. There are several categories: people's evaluation of the system features itself, and then how well that system allows them to deliver a certain service, and then their evaluations of their own feelings. I feel confused, I feel happy when I use the system, or I feel I can do a good job as a bank teller or as a physician by using this computer system. And then the system quality, which has been our main attention, and would be aspects of how the error messages are, how the screens are designed, whether the colors are helpful, whether the sequence of screens are appropriate. And in support of that, we've developed a standardized questionnaire for user interface satisfaction. I've included a version of that in your notes. and for you to get a sense of it. And if you're interested in using it, it exists in paper form. It's and also an HyperCard on the Macs and also on IBM PCs. If you're interested, Kent Norman, my colleague in the psychology department, is dealing with its distribution. If you contact him at 301-454-6388, he can talk to you about getting a copy that would serve your needs. We're interested in people putting this to work. We're interested in people giving us feedback about its strengths and weaknesses and ways of validating